Good morning, Algebra 1. Welcome to my basement. My husband hung up a blackboard for me, and it's cold, just like my classroom. So I have a sweatshirt. We're going to do some factoring problems if I get around to it. That's my bunny, Oreo, so if I'm distracted once in a while, it's because he's jumping by my feet, and I'm trying not to step on him. All right, let's do some factoring. So the last type of factoring we did together was differences of squares. And the difference of squares was when you had one thing that was a perfect square minus another thing that was a perfect square, and it factored into the sum of the two parts and the difference of the two parts. Okay? That's the rule. So, if I had something as simple as x squared minus 25. X squared, well that's x squared. 25 is 5 squared. So the parts, the a and the b, are x and 5. So this factors into x plus 5 and x minus 5. Another way we thought about this is that there's no middle term, there's 0 x's. 5 times negative 5 is negative 25. 5 plus negative 5 is 0. 0 middle term. Okay? All right, so let's say we've got x squared minus 49. Again, you should recognize 49 is a perfect square. The square root of x squared is x. The square root of 49 is 7. So x and 7 are your a and b parts. So this factors into an x plus 7 and an x minus 7. It does not matter what order you put those two parentheses in. If you put the subtraction part first and then the addition, it's the same thing. All right, I'm out of space. Let's make a couple trickier ones. Let's say we've got 9x squared minus 100. 9 is a perfect square. X squared is a perfect square. 100 is a perfect square. So the pieces, the a and b pieces, this square root of 9 is 3. Square root of x squared is x. Square root of 100 is 10. So 3x and 10 are the a and b pieces. So 3x plus 10, whoops. Three x minus 10. Okay? One more of these, and then we're going to do the part that we didn't get to before we all left. All right, let's say we've got, that's a 6. Okay. You should know the square root of 4 is 2. You should know that the square root of 121 is 11. So what's x to the 6th broken into two equal pieces? Well, one of the things Mr. Bosch pointed out was when that's an even number, that meant it could be split into two equal pieces. 6 divided by 2 is 3. So that means 2 square root of 4, x cubed is our a piece. So this factors into 2x cubed plus 11 and a 2x cubed minus 11. Okay? Difference of squares. All right. Let's go on to another one. Try a little water this time. Oh, much better. All right. So it kind of looks like our normal trinomials. And when we factored these, we always look for a GCF first. 9, 60, and 100 don't have anything in common. If we took the approach that we've normally taken, and we do 9 times 100, and we write 900 over on the side, and then we say, what two numbers can I multiply together to get 900 and add together to get 60? There's going to be a lot of options. This would work, but I need you to recognize something else about this problem. 9 is a perfect square. 100 is a perfect square. When I start and end with a perfect square, this is probably another pattern. Excuse me. This is 3x times 3x. So let's see what would happen if I started both with 3x. This is 10 times 10. Perfect squares. The whole thing is addition, so this whole thing would be addition. Now, let's verify if that works. 3x times 3x, boom, 9x squared. 10 times 10, there's the 100. Where would this one come from? Well, this one would come from those. 3x times 10, that's a 30, is 30x. 10 times 3x is also 30x. 30x and 30x, there's our 60x. So this factors into 2 of the exact same quantity. You are welcome to write it like that. That's the correct answer. But you could also go like that. Call it 3x plus 10, quantity squared. Well, let's do another one of those. Okay. All right. 16, 24, and 9. Nothing in common. 16, perfect square, right? Square root of that is 4. 9, perfect square. Square root of that is 3. Both ends are perfect squares. So let's see if that's what we need. 4x, 3, whole thing's addition, and then let's check if that's what we get in the middle. 3 times 4x, 12x. 4x times 3, 12x. That's what we needed in the middle. So you can either leave your answer like this, or you could have done that. All right? One more, and we're going to call it a day. Hopefully you can see that. Got the board a little too wet. I'll learn. All right. 4, perfect square. 25, perfect square. Both ends are perfect squares. So let's see if that's what's going to do it. 2x, 2x, 5, 5, Now here's where this one's a little different than the previous two. I need a minus 20 in the middle. That means both of these have to be subtraction. When I do negative 5 times negative 5, two negatives give us a positive, so that's okay. And of course, 2x times 2x will give us 4x squared. Negative 5 times 2x would be negative 10x. 2x times negative 5, also negative 10x. There's that negative 20x we needed. So, final answer. Either write that out twice, or write it like that. All right, you should have all of the factoring worksheets that I sent you complete, or getting ready to complete them now that you've seen this, okay? The answer keys are all right there with them, so you can do the work and then check them. If you feel like you need more review, do them a second time. I also posted some Khan Academy videos to remind you. I think I need to post one for this. I'm going to do some review of exponential rules starting tomorrow. But your goal today, finish all those factoring worksheets if you haven't done so already. All right? Miss you all. Hopefully see you soon.